We are group 5 and we are presenting on artificial neural networks. Artificial neural networks are computational models inspired by the structure and function of the human brain. They are composed of interconnected nodes or neurons that process and transmit information. Ants consist of three main types of layers. We have the input layers which receive data, the hidden layers which process and transform data, the output layers which produce predictions or outputs. Here are some key features of ants. We have the distributed processing, the scalability, the flexibility, and the ability to learn from data. We also have the various types of ants, which are feed-forward networks, recurrent neural networks, convolutional neural networks, and autoencoders. And ants may have many applications such as image recognition, speech recognition, natural language processing, predictive modeling, and game playing. So we are going to talk about the biological inspiration behind ants. Ants are inspired by the structure and function of the human brain, and here are some key aspects of the biological inspiration. We have the neurons, the synapses, the dendrites, the axon, and the synaptic plasticity. So over here we have a simple neural diagram to show the input layer, the hidden layer, and the output layer. Basic components of ants. We have the artificial neurons, which is the nodes, the connections, that's the synapses, inputs, outputs, activation functions, layers, weights, biases. These components work together to enable ants to learn, represent, and process complex data. How ants work. Ants work by data inputs, that is receiving input data, which could be images, sound waves, or text. Forward propagation, passing the input data through a series of layers. Then node compilation, have the layer interactions, the output generation, back propagation, training, and deployment. And then below we have a simple example of how an ant might work. Types of ants. There are several types of ants, including feed-forward networks, recurrent neural networks, convolutional neural networks, autoencoders, generative adversarial networks, transformers. Real-world applications of ants. Ants have numerous real-world applications across various industries, including computer vision, object detection and segmentation, facial recognition, natural language processing, text classification, and sentiment analysis. Benefits and limitations of ants. So, benefits of artificial neural networks: ability to learn from data, improved accuracy, flexibility. Limitations of ANS: interpretability, training time, overfitting, adversarial attacks. Brief history of ANS. In the 1940s, Warren McCulloch and Walter Pitts proposed the first artificial neural network model. 1950s, Alan Turing and Marvin Minsky work on neural network models. 1980s, David Rumelhout and James McClelland developed the backpropagation algorithm. Activation functions. Activation functions are used in artificial neural networks to introduce non-linearity into the model, enabling the network to learn and represent more complex relationships between inputs and outputs. Some common activation functions are sigmoid, rectified linear units, hyperbolic tangents, and softmax. Here's the end of our presentation. Thank you.